Example for chi-square test procedure. Suppose your instructor returns the exam and hand out the answer key. You construct a frequency distribution of correct response to the 50 items test as follows. Correct answer is A, you see it 12 times. Correct answer are B's, you see it 14 times. Correct answer are C's, you see it 9 times. D, 5 times. E, 10 times. And you add the numbers, 12 plus 14, 26, 35, 40, 50, okay? Yeah. So there are 50 questions. You find how likely you see A, B, C, D, E, okay, the frequencies. Now, the above is called the observed frequency table, okay, denoted by FO. And what do we want to see? What do you want to test? Your null hypothesis. The instructor shows no tendency to assign any particular correct response from A to E. One of my professors, when I was in undergraduate years, okay, this professor was just very strange. He liked to predict the correct answer, the last one, E, okay? So say 100 question, you may see E is what? Huh? You may see E as a correct answer, like 40 times. So correct answer E is what? Higher than 40%. So some students, if they did not prepare well, when they come to what? Something question in doubt, they only guess E. So to boost up their what? Their exam score, okay? So ideal situation, the correct answer should be what? Evenly distributed from A, B through what? Through E, okay? This is no hypothesis. Research hypothesis. Our research interest is the instructor shows a tendency to assign particular correct response from A to E, okay? And no hypothesis is the instructor shows no tendency. And research hypothesis is what? The instructor shows a tendency to assign particular correct answers from A to E, okay? And the expected frequency denoted by FE, expected. That's why we put FE here, okay? Are those frequencies that are expected to occur under the term of the null hypothesis. Now, if the instructor shows no tendency to assign any particular correct answer from A to E, then when you have 50 questions, okay, when you have 50 questions, each one should be what? Equally likely. So each one should be what? 1/5, okay? So each one is 10. So if the instructor shows no tendency to assign any particular correct response from A to E, okay, under H that is true. Correct answer A, you expect to see 10 times. Correct answer are B's, you expect to see 10 times. Correct answer are C's, you expect to see 10 times. So on and so forth, okay? Okay, so let's start over. Step 1, no hypothesis. The instructor shows no tendency to assign any particular correct response from A to E. Research hypothesis. The instructor shows a tendency to assign particular correct response from A to E. And step 2, we choose alpha equal to 5%. And step 3, okay, step 3, test statistic used. We use what? Chi-square test procedure. And how the chi-square test procedure is formed? It's summing up FO minus FE squared divided by FE. And our decision is to reject H naught if chi-square, the calculated chi-square value is too big. Okay? So this one requires some explanation. On the other hand, you can also use T procedure, okay? The test statistic you still use chi-square. And the decision is that we're going to reject H naught. If p value is less than alpha equal to 5%. So I'm going to use this two, okay? Let me begin with this one first. Okay, now step 3, test statistic use. We're going to use chi-square, and how we form the chi-square test statistic is FO minus FE squared divided by FE, and then we sum it up, okay? And the decision is reject H naught if chi-square is too big. And what is the idea behind this test procedure? Let me go into the details, okay? Look at here. Under H naught is true, what we observe should be close to what? What we expect, okay? Under H naught is true, what we observe should be close to what we expect. And that is to say, the difference between what we observe and what we expect should be what? Should be very small, should be close to 0, okay? And that further implies, okay, that further implies FO minus FE squared, okay, should be what? Should be small. Since FO minus FE is what? Close to 0. So for a small number, the square should be what? Should be still small. And that is to say, FO minus FE squared divided by FE. FE is what? It's frequency, expected frequency, okay? And this number is a positive integer, okay? So you divide this one, should make this one what? Even smaller. Can you see that? Should be even smaller, okay? For this part, we're going to cover later, some related concept later, okay? And this one should close to what? Should close to 0, okay? Because small number divided by a what? A positive integer. You should make it even smaller, okay? So, sum up whole bunch of small numbers. Should be what? Should be small. Okay, it should be small. So, you are not going to believe H naught is true. You're going to reject H naught. Because under H naught is true, you expect to see this number should be small. If you see this number is too big, you are not going to believe what H naught is true. So that's why your decision is to reject H naught if the calculated chi-square value, okay, is what? Is too big. Okay? That is the idea behind the test procedure. Okay, look at the decision here. We say we're going to reject H naught if chi-square is too big. Now, from this one, two questions raised. Question 1, how big you call it too big? To answer clearly about this, how big is too big, we need to know what is the t distribution first, okay? So next, I'm going to talk about property. Properties of what? Of chi-square distribution. property of the chi-square distribution, okay? Now, first one, property one. Chi-square is what? Is right skewed. This is a chi-square distribution. It's right skewed with a very long right tail, okay? With a very long right tail. And since it's square, so the smallest possible value is 0, okay? Since this is continuous, probability chi-square equal to 0, that chance is 0. Because chi-square is what? Chi-square random variable is a continuous random variable, okay? It's a continuous random variable. And the function to describe the curve we call PDF, okay? PDF, f of x. Just like a normal curve. Normal curve is also continuous random variables, okay? And smallest possible value is 0, okay? That's property one.